world's mass, temperature and chemical composition determine whether it has an atmosphere and what its composition will be. For a gas to be retained, the average speed of the gas particles must be sufficiently below that world's escape velocity. The escape velocity is a function of the gravitational force at the surface. For a given density, the escape velocity is higher for larger worlds, as in the example shown. Also, for a given size, the escape velocity will be higher for denser worlds. In general, the closer a world is to the Sun, the higher its average global temperature will be. Recall that temperature is a measure of the average kinetic energy of the particles of a substance. Kinetic energy is a function of speed. The greater the speed, the greater the kinetic energy. Thus, the higher the temperature, the greater the average speeds of the particles. However, the kinetic energy is also a function of mass. For a given speed, the greater a particle's mass, the greater its kinetic energy. Thus, for a given temperature, more massive particles will attain that average kinetic energy at slower average speeds. Thus, gases of heavy particles, like molecular oxygen, molecular nitrogen, carbon dioxide, etc., will be moving more slowly than lighter particles, like hydrogen and helium. This graph depicts the distribution of the particles of a gas at different temperatures. These can very loosely be compared to a bell curve or normal distribution of grades in a class. These are actually not normal distributions. At 100 degrees, the temperature is low enough, and the speeds of the particles slow enough, that even the fastest moving particles don't escape into space. At 200 degrees or higher, the faster particles do have the escape velocity and the gas does slowly leak off into space. As those particles escape, other slower particles will gain speed through random interactions and they too will escape. Eventually, all the gas escapes. If the average speed of a gas is less than 10% of the escape velocity, the gas is retained. If the average speed is greater, the gas escapes. A world is more likely to have a substantial atmosphere if the temperature is low enough and the world is sufficiently dense and/or large. Lighter gas particles are least likely to be retained than particles with higher mass because of the higher average speeds of low-mass particles.